Shoot.
Is
Um,
everything?
Hold on a second. I just
Yeah, it's okay. Is everything fine?
yeah,
You have it.
I just moved hold on, I think I can fix this. I just did something and moved Zoom to a new desktop, but I think I can fix that here.
Okay,
Yeah. Okay, good. All right.
nice. All right. So we're live. So hi everyone. My name's Yuri. I'm a CTO and co-founder of a company called Sombra. This is Sombra Around Tech, a stream of technical events, interviews, and meetups where we discuss interesting topics from the information technology space. And today with us is Mark Richards, famous software architect. Mark, welcome. Please introduce yourself.
Awesome. Thank you so much, Yuri. And my name is Mark Richards, and I'm a hands-on software architect. I've been in the field for, 37 years now. So quite a long time, but
Yeah.
still very active, doing a lot of publishing, a lot of training, and still some consulting as well.
Oh yeah, that sounds awesome. I mean, I checked your website. You have a lot of different videos, and also you participate in a lot of podcasts. And as you mentioned before, you had a lot of podcasts you took part this week. So how many like different discussions like this you take part during the week or month?
Oh boy, almost every day.
Oh, I could imagine. Yeah.
Yeah, I do so many conferences. I do a lot of podcasts and kind of interviews like this, which actually I really enjoy. The reason I can fit these kind of podcasts and Q&As and interviews is because they don't require any prep time for me. So it's easy to kind of fit it into my really busy schedule without having to prepare slide material or think about things. And so because of that, I'm actually able to do quite a few of them. I try to fit these hour-long slots in between either trainings, consulting, or working on material or books.
Oh yeah. Oh yeah. Yeah. That's that makes sense. And I could really double on that because please check the developer to architect.com website. There's a lot of different interesting videos from Mark, and they're also combined with really nice slides, really nice diagrams of everything related to the software architecture. So basically I encourage you to watch that. So I read, Mark, that you like hiking. Is that correct?
Yeah, that is hiking is probably one of my favorite activities or hobbies, I guess I'll say. And I try to do as much hiking as I can. Of course, I live in the Northwest in the United States, and it's still fairly cold. It's starting to get nice out, but during the winter, I replace that with a lot of snowshoeing when I can. You have to have snow to snowshoe, and this year there wasn't a whole lot of snow, so it was kind of a bummer. It was wet, heavy, slushy stuff, and sometimes it would rain, and so I didn't get out much this winter. So I am ramping up for the spring and the summer to be able to start getting back into hiking.
Oh yeah, that makes sense. Do you have like any memorable hikes, or things where things that you really remember?
Oh, let's see. How many hours do we have for this podcast? Oh boy, quite a few memorable. No, I'm just kidding. But yeah, there's been several memorable hikes. One in particular where we were hiking in the Grand Canyon, and it was at North Rim, which is the higher elevation. And we went off trail just to get closer to the rim, and we're camping at night. And ran across a mountain lion, and we're probably 20 miles from any sort of civilization or road. And it was a little scary. So that was one memorable moment. Another one, also in the West, in the Grand Canyon. Well, we mapped out this course goes back 25 years. So we still had topo maps back then. Can you believe it? It's almost like a typewriter.
Yeah.
But we had a topographical map that showed all the water sources. And well, after about a 3-day hike into the side of the canyon, the water source that we found was empty. And so that was a little bit of a panic. We ended up having to descend the canyon and found a little muddy hole that we ended up getting enough water out of. But yeah, I've run across a lot of those kind of things. No matter how much hey, this is really cool. You know why? Because it really relates to IT. No matter how much planning, careful planning and prep you do, things can still go wrong.
Yeah, definitely. That was like my next question. I mean, do you see any resemblance with the hiking and basically software development in IT?
Oh, so much. Oh, so much. Specifically, that last point about things just not working as planned. The weather's supposed to be perfect, and we'll go up hiking in the White Mountains of New Hampshire, and all of a sudden, a huge major storm will come in that wasn't forecasted. And we've been stuck in those situations. And that's kind of similar to everything going fine and all of a sudden something happening with the company or the project or servers go down or emergencies occur. Yeah, there's a lot of similarities. But also, I think one of the reasons I like hiking so much is I like being outdoors. I like that physical activity of just walking and seeing the outdoors. It gives my mind rest. It re-energizes me. But a lot of times, so does coding. Sometimes sitting down and actually writing code does that for me as well. There are times when you're running away from a storm or a mountain lion and it's no longer fun. Just like when you're coding on a deadline and somebody says this has to be done today and it's the worst code you've ever written. So a lot of parallels.
Totally. Okay. So you mentioned that you have 37 years of experience. That sounds really amazing. So the question is, how did you decided to be a software architect? Were there any decision like that at all? So, or how did you transition into that role in the past?
Wow. So I started back in 1985 as an architect. So it's been we're going back to the mid 80s now. But I started as just as a developer, and I did work with some architects back then. There were still architects existed way back in the mid 80s. But essentially back then, it was kind of something I always wanted to strive for. As a matter of fact, even when I graduated from my master's degree, I researched and saw that this role of, at that time, it was called systems architect, was in fact one of the top 10 jobs. And this goes back to mid 80s. It still is today, by the way. And so it's something I wanted to aspire to be making broader decisions, making more significant decisions that impact a lot of things other than just what was I going to name my function or variable. So I put in my time, and after 10 years, that's when I got my break to become a application architect. And so it was something I had always kind of aspired to. But Yuri, here is the very funny thing about that. I really wanted to be an architect to be able to make some major decisions, but something funny happened. I realized when I became an architect that you don't get to make your own decisions. Oh, you can propose a lot of things and propose a lot of solutions. But what I've learned is that almost every decision you make as a software architect will in fact be challenged. Very few people care whether you break a method into two parts, or you split apart a class file, or you create an interface for it, use some sort of design pattern. I mean, no one really cares much about that stuff. But when you start making architectural decisions about moving to microservices, or let's say cloud environments, or using a different cloud vendor, or all the host of architecture decisions we can talk about, a lot of people will disagree. Other architects will disagree because they're like, no, we shouldn't be using messaging here. No, we should be using this. It's like, no, I'm the architect. I want to use messaging. Developers will disagree with you because it's like, boy, that architect has no idea what they're talking about. And also business stakeholders will disagree with you because the things you're proposing are expensive and take a lot of time, and they don't want to pay for those things. So a message to everybody out there, if you're a developer, enjoy your life as a developer right now, because if you want to become an aspiring architect, you will lose a lot of that control over decisions. So the funny thing is I actually had it backwards.
Interesting. No, I definitely understand you, because when I was a software developer, I also thought that, hey, there should be a role where everybody is listening to me and my decisions, and they're executing them, and so I could really, play with them. And I mean, it sounds like fun, but I mean, it doesn't actually. It is still fun, but I mean, it's not as easy.
Right.
Yeah. In the end. So you brought up an interesting topic that I would like to discuss more. So you mentioned that actually no one really cares about that beautifully designed either interface or a beautifully refactored set of methods or anything. And so question is, what is actually like a software architecture? What is important there? How it's different from a software design?
Yeah, wow, lots of great questions there, Yuri, actually. So the first one, software architecture actually does matter. And I'm gonna start using some metaphors here, because one of the things we try to avoid are these big balls of mud, or big balls of distributed mud, where systems just through entropy start becoming unmaintainable. We keep throwing things at them, and suddenly it's just, I don't even know where to go to make this change anymore. And that's all about the architecture of the system. But it's also like buildings. So I've been all around the world, and I love when I go to different cities, looking at the different architectures, the different cultures, just setup of the cities and all that kind of thing. And I'm sure most of you have walked down the street and said, that is the ugliest building I've ever seen. Or these spoofs that you see on the internet. If you, I think as a matter of fact, if you Google ugly architecture, you'll see just that houses were put together without any thought about the architecture. And all of a sudden there's a door on the second floor that doesn't lead anywhere, or, these sort of things. Even if you look worldwide, both here in the US and also other places in Europe and beyond, where we've got bridges that are failing, that are crumbling down, and you see it in the news quite a bit. And so if we don't pay attention to the architecture, not only of physical structures, but also our systems, we end up in something called structural decay. Every system in the world, every building has structural decay. And it's one of the jobs of an architect to pay attention to that structure of the system. Now, what is architecture? And that's essentially what it is. It's the structure of a system. Now, that's kind of a frustrating answer, isn't it? Because it's like, well, okay, so now you're making me ask a lot of other questions. What do you mean about the structure? I know architecture is a structure, but what is the structure? And think about a house, or an apartment building that you live in, a flat. There's a lot of components there. The structure is the physical dimensions of the house, the way it's shaped, the floor plan, the size of the walls. These are things that are really hard to change and form the structural aspect of that house. And it's the same thing with software architecture. It's about the various services, the patterns, the architecture styles, the protocols, interfaces, dependencies between those, coupling between different components or services. This is all the structure of the system. Yep. And so that really is what I mean about structure. But architecture, I like to describe it in 4 dimensions to really understand what architecture is and kind of what an architect does. There's 4 things that you need to describe an architecture. If I said, I'm in my office right now, and the walls are 8 feet high.
Yeah.
Okay. I know nothing about the size of your office.
Yeah.
It's 15 feet wide. Okay. So I don't know. Is that still a small or a large office? Oh, it's 12 feet long. Ah,
Yeah.
now you just have visualized the office I'm in right here.
Yeah.
Because I use 3 dimensions. So when I say to you, Yuri, what's your architecture? Oh, microservices.
Mm-hmm.
Well, you're not really describing your architecture. You see, because it's only one dimension of that. I know nothing about your system other than one dimension, and that's the architecture style. So, what is architecture? It really is kind of 4 dimensions to describe it. The architectural characteristics, some people call these non-functional requirements or system quality attributes, ilities, things like scalability, reliability, availability, agility, testability. Which of those are important for your system? That's one of the first dimensions to describe an architecture because it does satisfy some of those. The logical components, the building blocks, is that second dimension. How the different pieces, the portions of that system are fitting together. And then, of course, there's the architecture style. Is it modular monolith? Is it event driven? Is it microservices? And then finally, and perhaps most important, what are some of the major architectural decisions that you made? And so really architecture is kind of those 4 main dimensions. And that's how I like to kind of describe software architecture. Okay. But you made another interesting question there, Yuri, which is, well, to better understand architecture, especially for the purposes of this podcast, what's the difference between architecture and design then? I mean, where does architecture end and design begin, or what are those? I'm going to go back to that house metaphor because it's such a, all metaphors are useful, but eventually they all break. But it's good to describe with this. So let's go back to that house. I'm thinking about the house I'm in right here, and it's 2 stories. That's part of its architecture. If I wanted to add a 3rd floor to the house, that's going to be really hard. Yeah, exactly. If I wanted to tear down one of the walls and expand a room, these things are hard. But I want to replace the carpeting. I'm bored with the color of my carpet in my living room. So I want to replace it. Or I want to put a lamp over here. And those things aren't impacting the structure at all. That's part of design. It's a good way to think about that. But to finally answer your question, it really is about 3 things to determine whether, and as a matter of fact, it's not whether something is architecture or design, because it's not a binary. It's where it fits in the spectrum. Is it more about architecture or more about design? Remodeling a kitchen is a great example. That falls right in between, doesn't it? Because it's going to be hard and expensive, and we're changing the structure, but we're not changing any walls. So it falls right in the middle there. So there's 3 things to think about. It's the thing that you're doing. Is it strategic or is it tactical? Strategic things tend to be more about architecture. Tactical things, more about design. And strategic, I'm going to qualify that. You need to make a particular decision. Is this architecture? Well, how many people are involved in that decision? How many people do you need to bring in and consult? How long is this going to take? If you need to consult with lots of different business stakeholders and operations and your development team and other architects, chances are it's probably strategic. Versus, oh, I don't need to talk to anybody but myself. Or maybe I'll email you, Yuri, and say, hey, what do you think about this? Yep, go for it. Okay. That's probably tactical. That's more about a design thing. That's number 1. Number 2 is the level of effort. is it hard to implement or change or revert back once you put that in?
Yeah.
Microservices. Yeah, we're going to move to microservices, and we start to do that. Oh, this is a mistake. It's going to take us a month to get back to where we were before, versus getting a new JSON parsing library. I don't like this one. I'm going to download this one and replace it. That's going to take me a half an hour.
Yeah.
And then finally is the significant trade-offs. If you analyze the trade-offs of something, if they're highly significant and impact a lot of things, it's probably more about architecture. But if there's not many trade-offs or they're not that significant, it's probably design. So that's really kind of the long answer to your short question.
Oh yeah. I mean, I really like one of the definition that you mentioned. Is it really hard to change afterwards? So that could be one of the questions to validate whether I'm making a architectural decision or a more design decision. So, yeah.
Well, this actually interesting. I think it was Ralph Johnson who said architecture is the stuff that's hard to change. And this has always been kind of a classic example of qualifying architecture. But it's interesting, if we talk about some of the latest trends in architecture, for example, it starts to actually refute that statement. You see, let's go back 20 or 30 years. We still had architecture, but how often did technology change? Or our platforms, or our environments, or even business. Now, business has certainly changed, but it would take years for a business to steer itself in a different direction.
Yeah.
But let's fast forward to now. How often does technology change? Oh, there's another UI framework. Just happened right there.
Just now.
Yeah, just now. Platforms change, and Java, the language, changes every 6 months. Businesses change monthly now, not annually, but quarterly to monthly. And so correspondingly, as it turns out, it used to be that business was the impediment to change. Not anymore today. Now it's IT and architecture. That's the impediment to change. So architecture is the stuff that's hard to change. Well, if we agree, and all of us do agree, hopefully, that the world is changing in all those dimensions at the fastest rate it ever has, then that means that architecture has to change at that same rate. So if architecture is hard to change, it will always be an impediment to progress. That is why I personally am so excited about new architectures like I say new architectures like microservices. It's only been out 10 years, so it's still in my mind a small child. But it does allow us that high level of agility, that ability to respond quickly to change, that evolvability and adaptability in architectures. Because we're separating our system into, single purpose functions that are separately deployed.
Yep.
I can add something faster. I could change something faster, but that's all architecture. I can add a new service just by dropping it into a container and popping it into Kubernetes, or just even writing a serverless function and deploying it right now. I mean, that's change. So it's interesting that I love this conversation. I have no idea how it came about, but it's great because one of the definitions that we're thinking of architecture, we're starting to see being refuted now, or we're trying to change that so that architecture isn't the stuff that's hard to change. It's kind of an interesting trend, one that I'm very, very excited about.
It's really a fundamental thought, because I always thought about the architectures as buildings, as you mentioned, and I always thought that the architecture are those walls that you simply couldn't move. But now, because the environment around is changing constantly, if something is really hard to change, then it's a problem. So that's really interesting thing how it's happening now, because you're definitely right. Like everything around is changing so fast that it's really not good if in the architecture something is really hard to change. So I mean, the definition is changing. Yeah, it's really.
And this here is one of the many drivers for this new kind of drive of application modernization, which a lot of companies phrase it as. But it's migrations, it's architectural migrations from large monolithic systems that are, in fact, more difficult to change to highly distributed architectures. Now, it's interesting. What we're talking about is facilitating change. We've tried to do this in the past through levels of abstraction. But the only thing you can't solve by additional levels of abstraction is additional levels of abstraction. So we've tried to abstract away things to kind of decouple them, to make them easier to change. But there's trade-offs with that as well, in terms of, well, what in the world does a singleton factory proxy bean do? No one knows. And so the problem is we start losing actually the concreteness of our systems. And in general, every time we add another layer of abstraction, we impact not only the understanding of what's happening, but also performance as well, especially in distributed architectures. So, there's trade-offs on either side. But coming back, I don't know where that tangent came from. Let's draw it back. We were talking about change. That's what we're talking, facilitating change. And microservices is one of those architecture styles, if appropriate, that allows us to do it. But we get great change, but we get great cost, great complexity. And when I say great, I mean a lot of cost, a lot of complexity, and also poor performance. And so, we have to realize that every time we start evangelizing and talking about how wonderful these kind of trends are, there still are trade-offs. And that's part of architecture as well.
So, thanks for sharing that. That's really interesting. I want to transfer now more to the topic of how engineers could become architects. So, for instance, I'm a software engineer with 4 years of experience, basically building various web application systems. And now I'm watching this podcast and really interested in the topic of software architecture. So what would you advise how a software engineer could slowly dig into the topic? Where to start?
I actually like to call this kind of topic about, how do I start becoming an architect? Or can you just push me in the direction of becoming an architect? I always like to think about it in terms of a phrase I use called architectural thinking. It's thinking like an architect, seeing a problem with an architect's eye as opposed to a developer's eye. And there's a lot of ways developers can do this. As a matter of fact, I love this topic because the more developers start thinking architecturally, that puts them on a track to become an architect. But even if they don't want to become an architect, it actually enhances their not only productivity, understanding of the problem, but also we get a better product as a result. So let me tell you what I mean by this architectural thinking, and to answer your question. The first is to really, I guess, with any kind of discipline, learn the language, the lingo. And the language of architecture is really in the form of architectural styles. There's 8 common, I mean, there's probably 12 I can list, but 8 common architectural styles that are out there. You know, the traditional layered architecture, the N-tiered that we've been doing for 60 years, the modular monolith, microkernel architecture, the pipeline architecture, and then things like service-oriented architecture, service-based architecture, microservices, event-driven architecture, and even space-based architecture. It's understanding what those look like and what the advantages and disadvantages are of those. Identifying those in your mind allows you to see a problem and kind of know which architecture style, the overall structure of our system, would match with that problem. Yep. And it's also seeing the system that you're coding with class files and seeing the bigger picture of the overall structure of what it is. So that's kind of really the first thing, is really starting to learn that language, those styles. But it's also part of architectural thinking is understanding those driving architecture characteristics, those ilities that are critical for the success of that particular system. Is it that time to market is the most important thing that the business has told you, that your product owner has said, that any change, any feature, we have to get it out faster than our competition? That's the kind of business we're in. Well, I'm not going to be concerned about performance or scalability. No, I'm going to be concerned about maintainability, testability, deployability. And knowing these characteristics as a developer allows you to start thinking architecturally to really understand, as we're implementing that problem, am I impacting any of these driving characteristics that are critical? Because that's what an architect does. These are the things in their daily job they actually address to make sure that in any given iteration, we haven't impacted the necessary scalability or availability of our system. Getting more involved in the business problem is another way of kind of getting towards that architecture role, thinking like an architect. You know, it's interesting. Developers, for the most part, knowing the business domain is a real nice to have. Yeah. But most of us are hired, I'm saying as I'm putting on my developer hat, most of us are hired for our technical capabilities, to be able to take a business problem and implement it in software, machine code. That's our expertise. And what happens is we get lost in the trees as developers. And by the way, no fault on that, because developers need to focus on the trees. Absolutely. But then we get lost in the woods and we don't see the whole forest and we don't see really where we're at. And starting to think about the business problem and realizing why are we doing this? What problem are we really solving other than that technical problem is another way of starting to think like an architect. Because in a lot of cases, it actually will influence the design of your code. I think one last piece, I guess, is really just to begin to start leading, just being a go-to person on your team, being able to put down what you're doing and helping others on a particular problem. Being that go-to person is a great catalyst for becoming that leader as an architect. And so and helping to develop those soft skills, which are so critical as an architect as well. So those are some tips I usually offer in terms of, how can I start thinking about architecture, become an architect? And you know what, Yuri, these are things anybody listening can start to do tomorrow. Well, tomorrow's Saturday. Can start to do Monday. Actually, if you're a real architect, then yes, you would do those tomorrow.
Okay, yeah, that makes sense. That's really interesting. So, yeah, I totally understand. So, another thing would be, so how does the day in life of software architect looks like, except for the Saturdays and Sundays working? So,
Yeah.
yeah. So, could you share that?
Absolutely. Attend meetings.
Yeah. Okay, so those are meetings, not coding, right?
Yeah. Do you have another question? No, I'm kidding. This is an unfortunate thing that plagues software architects is meetings. I think one of the biggest efforts I do on close to a daily basis is manage my time so I'm not in meetings. But yes, it's attending a lot of meetings because architects, and sometimes there's reasons for this, because architects do need to collaborate with pretty much everybody. The development team, certainly other architects, business stakeholders, operations, you name it. There's the product owner. There's so many roles and people and areas that an architect needs to collaborate with just to make sure everything's fitting together. And unfortunately, in most cases, it does require meetings. But I try to manage those by first understanding why you need me there and what we're going to accomplish. And if it's just to rehash something, generally I won't go to that meeting if I've got other things to do. But aside from, half your day being involved in endless meetings, it's really also about resolving conflicts that occur on the team. And that is close to, well, sometimes a daily activity as a day in the life of an architect. But those may be technical conflicts that occur. It may be, and in a lot of cases, it's an assertion or an assumption that I made as an architect that was wrong. The development teams try and implement this, saying, hey, this just won't work. And so it's getting involved. It could be a personal conflict on the team, two people not getting along. And at least in my opinion, that is one of the roles of a software architect, is to act as a mentor, a coach, and also a facilitator on your team. And that's what is meant by leading your team. Answering questions. I can't tell you, Yuri, I probably get 20 questions a day. And most of them are technical, some are logistics, some are process-based, but yes, you become the answer person for so many things, business questions, just you name it, all the categories. But also another kind of day in the life activity is really just kind of helping the team, making sure they're on track and that they have everything they need. But I'll tell you something though, and this is yet another trend, I would say, in software architecture. Well, I can't really call it a trend because it's more a fact. Architecture is iterative. Architecture evolves. For the most part, we have learned our lesson that you can't do big upfront design, hand those artifacts to a development team, wave goodbye, good luck, pats on the back, and take off. It doesn't work. Rather, developers really should be treating that initial design from an architect as the first draft of something, no matter how long you spend at it, because it's implementation that reveals all the details and refinements. And the reason I'm saying this is the other thing in the day of an architect, in the daily life of an architect, is actually continually evolving and creating that architecture. And it's because of this that it no longer works for an architect to draw up fancy diagrams and just hand them off and think that is perfect. It's not, it never will be. Things evolve. We don't have all the requirements necessarily. And if we do, I will a pretty good money bet that they'll change. And that may, and usually does, influence the architecture. So, part of that daily life is, I guess I would use the verb architecting. In other words, constantly coming up with new components, refining those components and services. So that's kind of, it's a busy day.
Okay. So one of the very common questions is, so if an architect is spending most of the time in meetings, in discussions, in getting those entities better understood, changing the architecture, but you still need to maintain your technical breadth. You mentioned that in one of the really nice videos on the website. So how do you combine that? What is the good practice from you to squeeze somewhere the time for maintaining the technical breadth?
Yeah. Oh, what a great question. I mean, all your questions have been great, but this is one that is near and dear to my heart. I do a lot of architecture training now, and I was in one particular public class about 4 years ago, and I started the class, asked everybody, what their role was, and this one gentleman came up and he said, well, I'm kind of taking the class because I want to find out what this is all about, architecture. But I know already I don't want to be an architect. I just want to know more about it. And I said, well, this is odd. I said, why? And he said, because I like coding.
Yeah.
And I said, I am so glad you're in this class because we're going to talk about that. But it caused me alarm because I wondered how many really top-notch, great senior developers are out there that would make the most excellent architects, but won't take that leap because they love coding. See, there's this perception, unfortunately, that once you go into architecture, you no longer code. And that's not necessarily true. And let me explain and answer your question. First of all, yes, with all these meetings, with all the daily life I just told you, when in the world do you have time to code? It is my feeling and belief that all software architects should code. Now, if you're an enterprise architect working with business stakeholders and the CIO to figure out roadmaps for major business initiatives, no. That's 2 steps above any sort of coding, unless you're interested. But if you're down working with development teams, it's still my belief that it is necessary to code. It's the best way, first of all, to gain respect, but also to step in. If there's a problem, somebody's out sick, somebody got pulled away, and we're close to the end of the iteration. That's the time to roll up the sleeves and say, okay, I can do this. So now back to your question. How do you keep current then if we're so busy? Here's some great tips. The first one, proof of concepts. If I'm trying to figure out whether we should be using streaming or just simple RESTful calls for these 2 communication points, I can sit there all day and ponder it. I can look at diagrams until my eyes bleed, or I could actually do a quick implementation of each, because that, Yuri, that is what draws out the trade-offs. So one word of caution to everybody out there, though, if you're doing a POC, which I do a lot of, here's my advice. Take the time to write your best possible production-ready code that you can, because you don't get a lot of practice as an architect doing that. Also, most of the time, the code that I write as a POC ends up as the reference code in the Git repo. And do you want your name associated with the worst hacked up code you ever did on some afternoon just to see if something worked? But anyways, just the other thing, though, that I do mostly is I write fitness functions. So a fitness function is a way of testing some aspect of software architecture or verifying that aspect. Are we impacting scalability with these changes? How are things trending over time in terms of our response times? Are they getting better or are they getting worse? There's a lot of tools that do this, but for some of the kind of fitness functions that I've been, well, recently, the past 4 years writing, a lot of that's custom written. And so this is also an opportunity to code and write these fitness functions because, first of all, I, as an architect, am responsible for them. Doing automated governance, things like ArcUnit, ArcUnit.net, NetArt Test by Ben Morris. These are tools that are written in Java or C# correspondingly that allow you to codify your architecture decisions. These tools are amazing. I'll throw Sonar Graph in there because that also extends it to C++ and I believe Python. But these are ways of being able to say, I made an architecture decision and I don't want to have to stand behind your back and make sure you do it. That's coding. Trying to take some easy stuff on the project, not the hardest stuff, because then you become a bottleneck for the team because you're always in meetings. But taking an easy screen, something that's not bad, because then at least you're still coding. And I have learned that I have the same respect from a development team, whether I am coding the most complex module in our system or one of the easiest screens. Doesn't matter. I'm still writing production code with my team. Okay. So these are ways. There's so many code reviews. We could just, if none of these work, offer or just take the initiative to do a code review. At least you're still involved in the code. You're reading code, and that at least helps a little bit. Yeah. So those 5 great ways of staying hands-on as an architect, being able to justify it.
Awesome. I mean, these are really good advices. So I propose now to transfer to the questions from the audience. Let me check.
Your questions have been great, by the way. I've loved the the tangents we've been taking on them. But yeah, I'm anxious to see if anybody from the audience has any questions as well, just about architecture or any kind of thing.
Yeah, just a second. Just trying to read through those. Yeah, so one person is really writing interesting things. So how do you think AI will change the role of architects? Will world need less architects, or they just adopt to new reality?
Oh boy, this is probably the number one question. Hold on, Yuri. I am going to go on to ChatGPT. Let me just sign in here. And I'm going to ask ChatGPT, how are you going to impact architecture or architects? No, I'm just kidding.
Yeah, that's a good idea. Yeah.
My friend Neil Ford and I have really been researching this topic quite a bit. And, AI is really good at knowledge, but not good at wisdom. And there's a difference between these two. AI will help significantly, for example, in, let's say, configuring Kubernetes. Okay, that's a task that requires some knowledge. However, should I be using orchestration or choreography for the workflows in my system? That's wisdom. And that requires a context, a specific context. It's interesting, and this is something that right now things like ChatGPT don't have, and I don't think ever will, because you have to have enough context and analyze the trade-offs within that context, given those architecture characteristics, to be able to make that kind of decision. It's kind of, and I just now lost my train of thought for a second. Anyways, so point is this. I don't anticipate that AI or ChatGPT will be replacing architects or architecture. Rather, if anything, it might become a handy companion when doing maybe some trade-off analysis or trying to understand the context of something. Oh, I remember what I was going to say. So one of the first things I did on ChatGPT was say, write me some code in C++ to do a merge sort. Yeah. And it wrote it. And it was actually, it worked. It was pretty good code. I said, now write it in Perl. And it did. Yeah. Now write it in C#, and it did. And my point is, it's like, okay, that's pretty scary. Mm-hmm. Write me some code to validate my order. Mm-hmm. Oh, it can't do it because it doesn't have any context. You see, for some of the menial tasks of, some of these common algorithms, things that don't require context, great. Absolutely. That's going to speed up my time greatly. But I don't think it's going to replace developers. Rather, it's going to allow developers to focus on the more difficult business context problem to code, rather than these kind of algorithms that we're continually going on to Stack Overflow or, Google searches to find. So I really, it's a great question. It's a very common one. And I really don't think it's going to impact architecture or architects now or in the future.
Yeah, that makes sense. And I would maybe add to that also that one of the important roles of the software architect is basically contacting people and asking questions and asking the right questions from people, then getting those answers. So with the ChatGPT, basically, you are asking questions to ChatGPT. ChatGPT is not asking questions to you. So that's another thing, So
yeah, exactly. It would take so long, and I understand where you're coming from on this because it is conversational. So I can imagine a conversation. Should I use choreography or workflow or choreography or orchestration for my order placement? Yeah. I can see the questions now. Well, tell me which architecture characteristics are important to you. And so I tell those down. Seems to me, well, tell me about, and this conversation would go on for days. And this is, I don't see it really because of that conversation needs to happen. I don't see it coming up with anything different or actually better than I would come up with because I have more context than it's asking the specific questions for. So yeah, it's an interesting conversation.
Loading context into the ChatGPT conversation would take a lot of time. So yeah, maybe I totally agree with you that it's really handy in consulting, but actually there's so much more in the architect's work. Being just trying to get 15 minutes of some stakeholder to speak with you and give you that information that you need and asking the right questions from the stakeholder. That I don't think as well about the replacing, but rather than giving a handy, being
exactly. Yeah.
So okay, so that was also the question. So, what's your favorite book?
Oh, my favorite book. Oh gosh, I'm not sure if I have an absolute favorite book. I'd have to say if I did. Probably The Fundamentals of Software Architecture. I've heard that's a really good book. No, I'm just kidding. That happens to be mine. I will have to say I have favorite authors. Carlos Ruiz Zafón is one. As a matter of fact, there's none that I have that's my absolute favorite, but it's definitely The Shadow of the Wind from him is probably on my top 5. I'm really big fan of Cormac McCarthy as well, a U.S. author who wrote The Road and a lot of those kind of books. That's interesting. I do have a reading list that's on my website. If you kind of go to the About Me page, I show all the books I've read for I think I started this about 5 years ago, and I rate them from a 1 to 5 star. And it's interesting because I encourage my friends to do this. Because if I finish a really good book, there's nothing more frustrating than saying, I'm not sure what to read next. And I love getting recommendations from my friends on a variety of genres, whether it just be science fiction, fantasy, which is one of my favorites. But if you look at my reading list, you'll see I've been deviating quite a bit from that lately, and it's been very refreshing. So yeah.
So basically, would you say in connection to the principle that software infrastructure, for example, the database engine, better be independent of the architecture and easily swappable?
Actually, what I see as a trend, if you were to ask me about the future of software architecture, is actually to bring data closer to the user and to processing. In other words, this ancient, and I say ancient because since the beginning of time, we've tended to create the database as this place we store data somewhere out there, and all these connections to it like tendrils, like an octopus. And then here's all the main stuff. Here's our UI and processing. And it doesn't work well. I'm not sure it has ever worked well. And I'm not sure what the answer is. Data mesh from an analytics standpoint is answering a very, very important question about how can we actually provide effective analytics and reporting of our data, not from a transactional standpoint, but data mesh is definitely a great trend in the right direction for being able to partition data into domains and bring it actually closer to the problem it's trying to solve. And so about it being replaceable, I will say, though, to all that comment, I am a fan of, and this comes back to microservices, of that abstraction of the data. This is one of the things I think microservices is doing extremely well because of the bounded context. And this could include multiple services sharing data, but in that bounded context, that data, regardless of the kind of database it is only accessible to those services or that service. So if I want that data, I have to ask for it. And asking for it gives me a different contract, whether I'm caching or doing a request, a RESTful call or whatever. That's a different representation of actually how I'm physically storing my data. And this gives me the flexibility of changing that storage mechanism, the schema, changing the database itself into something that's probably more suited other than the traditional relational database, maybe a columnar like Cassandra or KV database, a document database like Mongo. I am a big fan of those abstractions because what we found doesn't work is having all these applications, all these services accessing the same data because, boy, we make a change to that data and it disrupts the entire world. So kind of a two-prong answer there. I am a fan of abstraction of the data, but I'm also seeing the necessity of incorporating data closer to the processing and to the user.
Interesting. Okay, thanks. Thanks for that. So suggest please some consistent book about architecture practices, which includes architect languages, styles, etc.
Well, I do have to do a shameless plug here because Neil Ford and I's book that we published in 2020, so just a few years ago, The Fundamentals of Software Architecture, is unique in the space of architecture books in that we chose, and there's a reason it's in 3 parts, is to really cover all of the aspects of an architect. The approaches to understanding the business context and the characteristics is really about part 1. Part 2 goes into a chapter for every one of those architecture styles I mentioned. And then part 3 talks about how to make decisions, how to negotiate, how to lead teams, how to analyze risk. It's all of the techniques and soft skills of an architect. And
Awesome.
that tome bridges all three of those together, which all three really are needed in architecture. So, shameless plug to our book, but it does, and that's the reason we wrote it as a differentiator from a lot of other good books that are out there, but very specific of some aspect of architecture.
Awesome. So thanks for sharing that. Thanks for answering all the questions. I'm really sorry for the audience if I didn't ask all the questions because there were a lot of them. So Mark, thanks a lot for a really interesting discussion. Thanks for sharing your immense knowledge and experience. It was really, really nice talking to you. And would you like to say anything else?
Sure. Just one other thing to thank you so much for having me on your podcast. The questions were great. I thought this was a lot of fun. And I don't know, I find these podcasts just a great way to be able to just let everybody know more about software architecture. So really happy to be on this, and thank you so much.
Yeah, thank you. Thank you, Mark. Thanks, everyone, for listening to us. Subscribe to our channel and have a great day.